Welcome to Sundar's lecture. So in the last lecture, we have seen these topics that we have started DC circuits, and in DC circuits, we have told that we should know two basic laws to understand the electrical network, and those two laws were Ohm's law and Kirchhoff's law. So Ohm's law, we know this, V is equal to I into R, which means V will be directly proportional to I, right? Kirchhoff's law, we have two different laws in Kirchhoff's. Uh, Kirchhoff's current law, that is in a node, whatever the current, summation of current entering towards the node will be equal to sum of the current flowing away from the node, right? That is the Kirchhoff's current law we have seen. And we have taken the Kirchhoff's voltage law. What is Kirchhoff's voltage law? Sum of the potential rises will be equal to sum of the potential drops. And we have seen how to write the Kirchhoff's voltage law. For our convenience, we have changed the uh, procedure to write the Kirchhoff's current law, so that it will be very easy. I have told you in the last class, right? Now we will start with a numerical problem. We will take a single numerical problem and we try to solve by using Kirchhoff's voltage law and Kirchhoff's current law. We are going to apply the Kirchhoff's voltage law and the Kirchhoff's current law, right? So I will write here, we are going to apply KVL and KCL in numerical problem. And we will see so many things, numerical problem. And we will see so many things means, we will see what is power absorbed or power delivered in a network. That should be equal. Whatever the power is delivered by the network should be absorbed by some of the elements, right? So we will see one by one. So first we will take a problem, right? So this is the problem given to us. You see here, we need to find current in all the resistors. So this is the question given, right? So find current in all the resistors. Now you see, this is the problem given. We have two loops, right? This is one loop and this is the second loop. So whenever you see a problem, you don't see whatever the questions asked you to find, right? So you don't see that. First you look into the problem, you see there are two loops. So what you do, straight away you take the current directions. This is I1 and this is I2, and I am repeating this again and again. These current directions were assumed by us. After completing the problem, if the values of I1 or I2 becomes negative, then we will reverse it. So you don't worry about the direction of the current, whatever we are taking in the initial stages of solving the problems, right? So you see, we have taken this is I1 and we have taken this is I2. That's all, right? So now what you do, we know, right? So first you put the current directions in all the resistors. So this is in first loop. So in the first loop you put this is I1, and if you come like this, and I1 will come like this, right? Because it has to travel like this. So this direction will be I1 in 4 ohms resistor. So this will be I1. That's all, right? Only 2 resistor in the first loop. That we have drawn the current directions. So next you go for the second loop. So you see, this also we have assumed in the clockwise direction. So start from here. So you have to go in this direction, right? So if you go in this direction, you see your I2 will flow from bottom to top, right? So you just put the current direction in 4 ohms resistor. I2 will be like this. Then you come like this, and you see you have to travel this way because I2 is traveling in this way. So you put I2 in 6 ohm resistance in this direction. So this will be I2. And I have told you already, don't put any current directions for voltage sources, right? So this is the current direction. Now you have to write two expressions. That for this loop you have to write a KVL expression, and you have to write a KVL expression for this loop, right? So you try to write that. We know that. So you for that you start from this point. go in this way, come here, and you stop with this point, right? So first I will start in this point. So if I'm going in this way, because my current direction is like this, I'm going in this way. So from I'm traveling from minus to plus. So what I have to do? I have to put plus 10 volt. Then I'm going in the same direction as this current. So I have to put a minus. So minus, what is voltage there? 2 ohms into I1, right? 2 into I1, that is the voltage. So you come here and you are coming in the same direction as I1. So what you have to put? Again you have to put minus 4 ohms into I1, right? That is I1. What is the voltage here? Under this 4 into I1, and you are coming in the same direction. You see, you are coming in this direction, but I2 is in the opposite direction. So what you have to do? You have to put plus 4 into I2. That is also voltage, right? So 4 into I2, that's all. You have ended up where we have started, right? So this equation now becomes 0. Now what you do, you would rearrange this expression, right? So rearrange this expression, what you will get, first you will get, first you try to write what is I1 and then I2. This constant you take to the other side, right? So now you see I have a plus 10 here. So what I will do, I will bring all these terms to the right hand side. So if I do so, what I will get, this is minus 6, right? So okay, fine, I will write here anyhow. So plus 10 you keep as it is. So if you take I1, it will be minus 6 I1 plus 4 I2 will be there, will be equal to 0. And what I will do, I will keep this 10 one side and I will bring all these terms to other side. So what I will get, 6 I1 plus 6 I1, because I have taken to the 6 I1 to the other side, and minus 4 I2 will be equal to 10. That's all. So this is the expression number 1 for us, right? So now what you do, you go for the second loop now. So start from this point, go this way and come here, come to this point, right? So now I will start from this point, I will go in this way. If I go in this way, I'm going in a direction as I2, right? So same as I2. Now what you have to do? So I will write here anyhow. This is for first loop KVL. Now I will write for the second loop KVL. Then only you can easily understand, right? So you start from this point. So I am going in this way. So this will be minus 4I2 minus 4I2. Then I'm going in this direction because my I2 is like this. So I'm going in this direction. This I1 is coming opposite to me, right? So if it is opposite, then what you have to do? Obviously, you have to put plus 4 into I1. Then you go in this direction. You see, you are going in the same direction as I2. So what you have to put here? Minus 6 into I2. Then you come in this direction, and now you see you are coming from plus 2 minus in a voltage source. So if you are coming from plus 2 minus in a voltage source, what you have to do? You have to put minus the value of voltage, that is 5. That's all, right? You have no other elements in this row. So you put this one equal to 0. That's all. Now you rearrange this sentence and you put I1, I2 in one side and constant in other side. This constant is minus here, so I will bring this to right hand side. That's all. So if I do so, what I will get first, I have only 4 I1. So that is only one thing. Then if you see I2, there are two terms. So what you will get, if you simplify that, you will get minus 10 I2 minus 5 equal to 0. So if I bring this constant term to other side, what I will get? 4 I1 minus 10 I2, which is equal to 5. That's all. This is equation number 2. This is equation number. Right. Now you have two equations, right? You can easily simplify this. So solving two equations, I'm getting. So you try to solve these two equations so that you will get I1 and I2. So I am getting I1 is equal to 1.82 amperes and I2 is equal to 0.23 amperes on solving the I1 and I2 expressions, right? That's all. Now we have found, you see, try to understand, these two are loop currents. These two are loop currents. We have found loop currents, but what is the question asked? Find current in all the resistors, right? We have to find. Now both the answers are positive. If both the answers are positive, then whatever the current directions you have assumed, that is correct. That's all. If the answers are positive, you can conclude that the current direction assumed by you is correct. If it is negative, if any one of these two answers becomes negative, then you have to reverse the current direction, whatever you have assumed in the beginning of solving the problem, right? So right, fine. Now these two are correct, no problem, right? Now they are asking you to find what is the current in the resistors. You see, you consider this 2 ohm resistor now. This 2 ohm resistor is only connected in the first loop. There is no relation between 2 ohm resistor and this second loop, right? You see, this 2 ohm resistor only connected in the first loop. So simply you can write, what you can write here, I through 2 ohms resistor will be equal to, only it is connected in first loop, so that I can write it will be only I1. That's all. It is very simple to understand, right? It is only connected in first loop, so the current flowing through this 2 ohms resistor will be only I1. That's all. Now you come to this 6 ohms resistor. There is no connection between 6 ohm resistor and loop 1, right? You see, loop 1 is here, there is no connection. Only it is connected in the second loop. So you can easily write this expression also. I through 6 ohm resistor will be I2. That's all, right? I2. That is nothing but 0.23 amperes, right? That's all. Now what you do, you have to find what is this 4 ohms resistor current. You consider this 4 ohm resistor. It is connected in first loop as well as it is connected in second loop. If you see like this, any resistor connected between two loops, then you have to apply Kirchhoff's current law. That I will tell you. First, for that I will redraw this diagram. Right. So this is the diagram. Now you see, you have to consider that what is the current flowing in the 2 ohms resistor. That is what we have found. That is also in the same direction as I1, right? So 2 ohms resistor will have, what is the current value? That is nothing but it is 1.82 amperes. As well as what is the current flowing in the 6 ohms resistor? 6 ohms resistor, that is what we have found, that is 0.23 amperes, right? So what is this current? This will be 0.23 amperes. Now you see, I need to find what is the current in 4 ohms resistor, and I don't know the direction of the current. So what I am doing here, I am going to assume, right? Assume. How I will assume this current now? I am just assuming that this current will be like this. I am putting this as I through 4 ohms resistor, right? I need to find this value now. So now you see, what I have already told you, what is a node in a circuit? If there are 3 branches connected at a particular junction, then we call it as node, right? So you can easily tell this point, which is nothing but this is a node. So what you do, apply KCL at node A. That is what we have done, right? So for that, what you have to do, you have to put a equal to symbol first. Now you see 1.82 amperes is coming towards the node. So what you have to do, you have to put that in the left hand side. So 1.82 amperes is coming towards the node, and you see this 0.23 amperes is leaving this node. So you have to put it in the right hand side, right? So what you will do, you put it in the right hand side, 0.23. And also I through 4 ohms is also leaving the node. It is going away from the node. So you have to put it in the right hand side. So you will get plus I by 4 ohms, right? So now you need to find what is I by 4 ohms. So if you want to find what is I by 4 ohms, you bring this 0.23 to the other side. So you will get what? 1.82 minus 0.23, right? So now it is easy to understand that I through 4 ohms will be equal to what I am getting. If I minus these two, I will get 1.59 amperes. I will get 1.59 amperes. That's all. So we have found all the values now. All the values were found, right? All the values were found. So we have found all the values, right? I through 2 ohms, I through 6 ohms, and I through 4 ohms. So that is what asked in the question 2, right? You need to find what is the current in all the resistors. Now you see, with the same problem, we have used Kirchhoff's voltage law as well as we have used the Kirchhoff's current law. That's all. This is the application of the Kirchhoff's voltage law and Kirchhoff's current law now, right? Now I have to tell you one thing very clearly. Let us take a new page for that. So that topic will be, so this is power balance in electric network. For that, you need to know one thing very clearly. What are all the sources of the power in an electrical network, and what are all the elements that is absorbing power in an electrical network. You need to know the basic of these two things, right? For that I will explain you. I have already told you, anyhow I will tell you again. So if you take an element, I am not telling it as resistor or it is a voltage source or anything. I am just drawing the element, that's all. So this is one element. In this element, if this term is minus and this terminal is plus, and if the current flowing is like this is I. So if you see anything like this, so the current is flowing here from minus to plus. If it is so, then this terminal will be nothing but power delivering terminals. Power deliver, right? Power delivering elements or this element is delivering power to the electrical network. That's all. Now I am drawing the same diagram again. You take like this, same thing. So if I will draw like this now, this is plus, this is minus, and if current is flowing like this, now you see current is flowing from plus to minus. Here it is minus to plus. If it is flowing from plus to minus, then these elements will absorb power. So power here will be absorbed, right? These two you have to understand very clearly, right? Now we will take the same problem and I will tell you how power will be balanced in an electrical network, right? So we will take the problem, right? Now you see here, I have taken the same problem, whatever we have seen in the KVL KCL example. You see current in the 2 ohm resistor and 6 ohm resistor and 4 ohm resistors we have found already, and I have told you already that resistors will never deliver power, right? You have to understand. So always resistor, if you see a resistor, current will flow from plus to minus. There is no difference. You cannot change this, since resistors cannot deliver power, it only absorb power, right? So this will be plus and this will be minus. Now you see, whatever the elements are delivering power in this circuit, that is the question now. Now you see, this is current direction, right? This current is flowing from where? From minus to plus it is actually flowing, right? You can clearly see that this 10 ohm, this 10 volt source is delivering power in the electrical network, in this circuit. In this circuit, this 10 volt source is delivering. And you see this current, it is traveling from plus to minus, then obviously this resistor is absorbing power. And also this 1.59 amperes of current is flowing from plus to minus in this resistor, that is also absorbing power. And this 0.23 amperes is going from plus to minus in 6 ohm resistance, that is also absorbing power. And this 0.23 amperes of current is also going from plus to minus in this 5 volt source. See this is very important. This current, that is nothing but the same current will come here, right? There is no difference. The same current should also come here, since it is series circuit. The 0.23 amperes will come here, and you see that is also traveling from plus to minus. Then obviously this 5 volt source in the circuit is not delivering power, it is absorbing power. That you have to understand. That is why I have taken a problem like this, right? So now we will solve the problem. So only this 10 volt source is delivering power. If you take any electrical network, I will write here. If you take any electrical network, power delivered, power delivered should be equal to power absorbed. Absorbed. That should be very interesting, right? So now what I will do, only 10 volt source is power delivering, right? So power by 10 volt source we need to find. How we can find power? So for formula for power we have two different formulas. Either it can be V into I, or power formula can be written as I square R. That we know already, right? So now you see this P by 10 volt, I have voltage and also current, right? This 10 volt source, how much of power it would have delivered. It is delivering. How it is delivering, since my current is traveling from minus to plus, obviously, right? So this will be delivering power. So I will write here power delivered. Only this one is delivering power, right? So power delivered. So from minus to plus, what is the voltage value here? So V into I formula. So 10 volt into what is current value? 1.82 amperes, right? So obviously, what is the value of P by 10 volt? That is, this power is delivered, and if you multiply these two, you will get 18.2 watts. Right? This is the power delivered. So power delivered in the circuit is only 18.2 watts. Now I will find power absorbed. Power absorbed. Power absorbed, there are 4 elements, right? This 2 ohms resistor, 4 ohms resistor, 6 ohms resistor, 5 volt source. All are power absorbed elements in the network. So I will see, first I will take power by 2 ohms resistor. What is 2 ohms resistor power? How we can find the 2 ohms resistor? Since I have resistance and current, I use this formula, I square into R, right? So if I do so, what I will get? I square 1.82 the whole square into 2 ohms. So if I solve this, I will get 6.62 watts. So for next thing, I'm going for 6 ohms resistor. So if I take 6 ohms resistors, P by 6 ohms will be equal to, again I have current and resistor, so I use this formula. So what I will get in this one? So that will be 0.23 the whole square into 6 ohms, right? So if I solve this, I will get 0.32 watts. Now I will take P by 4 ohms resistor, this 4 ohms resistor. So 1.59 amperes is flowing in the 4 ohms resistor, right? So P by 4 ohms resistor will be equal to 1.59 the whole square into 4, right? So I will get 10.112 watts, anything. So next I am going for, this is also power absorbed, right? Since my current is flowing from plus to minus, then this voltage source is also power absorbing element, right? So P by 5 volt source. So here you see, I have voltage and current, right? So I use this formula, V into I. So if I do so, this is V, what is V? V is 5, and what is I? 0.23. And if I simplify this, I will get 1.1. Anyhow, I have to move this. Right. Now you see, I will get 1.15 watts. That's all. Now you see, what I have already told you, power delivered will be equal to power absorbed. That should be equal, right? Now I have written what is power delivered, that is nothing but 18.2 watts, and power absorbed by 4 elements in this circuit. So I have solved all the power absorbed by the elements. What is the value of power absorbed, right? So if you total this value, if you add all these values, then you will get 18.2 watts. That's all, right? You add this, you will get, obviously you will get, so 6 plus 10, you will get 17 here. Then if you add these two, it will be 18.2. So 18.2 watts. Now you see, power delivered in an electrical network will be equal to power absorbed in an electrical network. That you have to understand. This is very important. Power balance is very important. whatever the power you are giving to the electrical network, that should be absorbed by the elements, right? That should be absorbed. So if you get these two values correctly, then whatever the values we have found, that means this 1.82, this 0.23 or 1.59, all the values are correct. This is also one of the shortcut method to find whether your answers are right or wrong. Right? So this is also very important. Right? Now you see, I will tell you one more thing. In the previous slide, I want to take the previous slide. Here, you see here, I just want to tell you one more thing. So you take this one, you take only this node, these three elements, and I will tell you one thing. So I am just drawing it here anyhow. So this is like this, right? This is like this. Only this part. I am just taking this part. I am just telling you one important thing that you can understand without applying the KVL. You need to find what is the current in another other branch. So you see, current, this is 1.82 amperes, and this is nothing but 0.23 amperes, and I just need to find what is the current here. This is nothing but I by 4 ohms, right? This is the node A. So now you see, if you have a node, if you give some current, if you take a node, in this node you are giving 1.82 amperes of current, only 1.82 is coming towards the node, right? So 1.82 amperes of current you are giving to this node, and these two are going away, right? So you see, 1.82 you have given, and you are taking 0.23 in this branch. Then how much of current would have flown in this branch? Right? 1.82 you have given, and 0.23 you have taken out. Then obviously this branch will get 1.82 minus 0.23. We are giving 1.82 and you have taken 0.23 amperes through this branch, then obviously this branch will take 1.82 minus 0.23. That is what we have found here. So you see, if you are going for KCL, Kirchhoff's current law, you don't need to put the formulas and all. It is very simple to understand. If you know two branch current, and if you need to find one extra branch current, you see how much of current you are giving in, that should be delivered. You in a node you cannot store any currents. Whatever the current it is getting, it should be given out through the other branches. So this is very simple to understand, right? So you keep this in mind. Anyhow, we will put like this, but while solving the problems, you are going very deep into the electrical network. You don't use any formulas. You just understand all the concepts. That is very precious, right? Because electrical network is like a playground. You can play anything in that. Right? Okay, fine. Thank you. We will see in the next class. We will take the some other numerical problems, and we will find different topics in the electrical network. Right? Thank you. If you have any doubts, you please post it in the comments, and I will reply for that. Thank you.